What is CIP Security? So CIP Security was introduced in a new volume within the CIP specification. It was introduced over 2 years ago, so we published it a while back. And it currently defines the secure network enhancements for EtherNet IP involving TLS and DTLS. So the TLS is used for the TCP traffic, and not surprisingly, the DTLS is used for the UDP traffic. With CIP Security, you get several fundamental qualities of security. So you get a device identity that's provided by either an X509 certificate or a pre-shared key. You get device authentication that's provided through the TLS or DTLS handshake. Data integrity provided by an HMAC that again is in the TLS or DTLS tunnel. And then the data confidentiality provided by the TLS, so by AES encryption essentially. Okay, so what threats does this mitigate? So the HMAC mitigates several threats for the secure messaging. So any sort of threats against message tampering, replay, message insertion, essentially any of the I aspects with the CIA triad, you're mitigating that with the HMAC that comes along with TLS and DTLS. Communications eavesdropping, that's obviously mitigated by the AES encryption. And then unauthorized communications, again, the endpoints have to authenticate through a secure handshake using their certificates or their pre-shared keys before they can talk on the CIP network. And then that's what we have right now. To be added in the future, I'll talk a little bit more about this later on in the presentation. But in the future, we're also going to be adding user authentication, flexible policy management for authorization, and then logging and auditing, all within the CIP protocol. Okay, so how does this work? So CIP Security, again, it uses TLS and DTLS to mitigate the risk of Ethernet-based attacks. And an important point here is that these technologies are used unmodified to protect the Ethernet IP communication. So whatever application you have in your CIP communications, whether it's a CIP motion or CIP safety or anything else, HMI communications, that just rides on top of your secure tunnel. So the asset owner, they don't have to do any additional work to modify their application in order to use the secure tunnel. It's just a tunnel, and then the communications flows through it, whatever the application happens to be. Okay, so if you like to see protocol stacks, I know this is the technical stage, so hopefully people appreciate this type of diagram, but essentially we have the one side has the I/O, and the other side has basically the messaging or the configuration that gets sent over CIP. So that's the TCP side, and on top of that is the TLS. Then you have the Ethernet IP encapsulation. Then there's your unconnected messaging, or what we call class 3 messaging, which is basically configuration to objects, and then your application on top of that. Other side is the I/O, again with UDP, DTLS, and then that basically just encapsulates raw I/O data that gets transmitted. So again, it's basically kind of the same way that it would work in your internet use case using TLS and DTLS with TCP or UDP. Okay, so I really do want to put some emphasis on this point. I know this is, I'll say, somewhat of a contentious issue. We're having a debate right after this presentation around whether or not TLS is appropriate for industrial protocols. But I think you can tell what ODVA's stance is on this. We wanted to use TLS and DTLS as the essentially pure and unmodified version. We didn't want to invent something our own. We just wanted to use basically what has been used for many, many years in the internet and information technology space. We didn't modify TLS and DTLS. We rather took CIP and adapted CIP to use those technologies. So one of the big advantages of that is that a vendor could go ahead and pick up a commercial or open source TLS library and just basically use it directly. They don't have to do a bunch of additional work to modify the library or roll their own library because we did something totally different. You essentially could get OpenSSL or any other library that implements this and use that for CIP security. And again, we did not want to invent something new. TLS and DTLS are already highly vetted. They're thoroughly tested. They're used very widely. Obviously, there's some high-profile cases of vulnerabilities being discovered, but those have been fixed. And we believe that all of the coverage and all of the usage of TLS and DTLS was good enough for what we wanted to do. So we basically just used what we have existing for our industrial communications. The only point I'll make here is that we did make use of some slightly less well-known features of TLS and DTLS. So one would be null cipher suites. Another one is the mutual authentication to authenticate both endpoints. And then we defined a couple mandatory cipher suites that all endpoints must support in order to ease interoperability. Okay, so another thing that we did with CIP Security is we took on the problem of configuring the certificate management and key management in a common way. So if you're familiar with CIP, there's a pretty strong object-oriented model where you have several different objects that you can use to configure various applications. So that's the same type of model that we use for CIP Security. So we define things like a certificate management object to manage your certificates. We have an EtherNet IP security object that manages things like the allowed cipher suites, whether or not you're going to do mutual authentication or one-way authentication. What type of trust you have. You can define additional trust authorities, things like that. So this allows for a common ecosystem of tools to use across different vendors. So as long as the asset owners, or I'm sorry, asset implementers implement the same objects, which they have to in order to pass the CIP security conformance test, then you should be able to use any common tool to configure the certificates, the pre-shared keys, the trust, the cipher suites, all of those things that you need to get TLS and DTLS to work. So it all goes through this object model. Okay, so I'll talk a little bit about how the configuration gets bootstrapped. So, this is always an important question when we're talking about secure communications. How is trust initially configured? So CIP Security requires that all endpoints implement a default certificate. And that default certificate can be used to bootstrap a TLS connection, which can be used to send down a new user-defined certificate and all the configuration needed for the CIP Security connection. So that certificate ideally will be signed by a vendor-owned PKI. So if you have a vendor, for example, Rockwell Automation, we would have a PKI that we own, and in the manufacturing process, we will provision our endpoints with a certificate signed by Rockwell Automation that can be used to bootstrap the communications. And then whatever other vendors, they would sign their default certificates as well, so that you could trust a vendor certificate in order to do your default configuration. Now, this is optional. We recognize that it's not always possible to do that. So you might have a case where you have software installed on a PC. It would be fairly difficult to sign a vendor certificate on a PC like that. So in that case, it would have a self-signed certificate. So it is allowed to have a self-signed certificate, but ideally, endpoints, especially things like PLCs and adapters and HMIs, things like that, would have a vendor-signed certificate that could be used to bootstrap the communications. Okay, a little more about this. There's two models that are defined within CIP Security for bootstrapping your communications. One is called the push model, and the other one is called the pull model. It's up to the user which one of these they want to use, although the pull model is automatic, and it basically occurs unless the user explicitly disables that. So I'll talk a little bit more about both of those. With the push model, this is basically the client tool connects to the device, and it sends CIP messages, and again, when it connects, it creates a TLS connection, and then it sends a bunch of CIP messages to the objects in order to configure the certificates and all the configuration needed for CIP security to work. So essentially, it's pushing all the configuration to the device. And the trust here is basically this TOFU model, trust on first use. So whatever gets to the device first, that's what's able to provision it. So you could use several different models for this. I mean, one way to do it would be to have a secure network where you provision your devices before they get deployed onto your OT network. You don't have to do that, but that is certainly a way that is suggested for customers to utilize this. The other one is the pull model. Earlier today, there was some talk about autonomic networking and things like that. So this is sort of in the similar vein as that. This is an automatic way for a device to, without any prior configuration, to wake up, discover where it could get a certificate from, request that certificate, and then be granted that certificate. So basically what the device will do is once it has an IP address and it's on the network, it will use DNSSD, that's DNS Service Discovery, using multicast DNS in order to try and discover where an EST server is. So EST is Enrollment Over Secure Transport. It's an IETF standard. And that is basically a way that a device, or really anything, can request a certificate. So the device will discover the EST server and then use EST in order to request a certificate to be provisioned to itself. So a little more on the trust with the pull model. So the question would be, well, okay, a device tries to discover an EST server. Does it just trust any server that it discovers? And the answer is yes, it does. It's the same model as the push model, where it's trust on first use. So in the push model, it was the first client that gets to the device is able to provision it. With the pull model, it's the first EST server that the device discovers is the one that provisions the device for its certificate. The more interesting question, though, is what does the EST server trust? And this is really up to the user to configure. They can use a number of different models for this, or really anything that they want to do. They can configure their EST server policy themselves. So they might have something like it would trust anything that has a valid vendor certificate. So you could configure it to say, okay, if you have a Rockwell device, a Schneider device, a HMS device, we will trust all of those things. You would automatically get a certificate from the EST server. You could have something where it gets put onto a list, and then an administrator has to log in to approve that. That's a more manual process, obviously. You could have the EST server send a notification to the administrator through text message or SMS or email to say, look, a new device is requesting to have a certificate provision. Do you approve this or not? You could have an inventory management system that would approve this. You know all of the serial numbers of the devices that you have in your spare parts bin, and if you see one of those requesting a certificate, then it's automatically granted. Or you could do any combination of those things. So really, it's essentially up to the user. The sky's the limit, basically, for how they want to configure the EST server to grant certificates to endpoints. Okay, so a question that always comes up when talking about this, and it's obviously a big concern for people who are using industrial protocols, is what about the performance of CIP security? So that's obviously something that people are sensitive to, and within ODVA, we've tried to do a couple things to try and mitigate that a little bit. So the first thing is that CIP security allows for the use of null cipher suites. So if you're not familiar, a null cipher suite is basically a cipher suite that doesn't allow for confidentiality. So it has the HMAC on it, so you have the integrity of the communications well protected. It still has the authentication through either a pre-shared key or a certificate handshake, but it doesn't have the AES encryption. So you allow the communications to go in the clear, but you still have the integrity. And that's probably okay for a lot of industrial applications. If you have things like I/O controlling a robotic arm, for example, you probably don't care so much if somebody sees that you're moving the arm a certain distance. But you don't want somebody to modify that, obviously. That would be really bad. So in that case, you don't need to use the extra overhead that confidentiality would bring. So we would recommend using a null cipher suite. Now, there could be situations where you don't want to do that. If you have secret recipe data that's being downloaded to a particular PLC or something like that, confidentiality is probably really important. So in that case, the performance is probably not as important, but the confidentiality is. So don't use a null cipher suite. Use one that does define confidentiality. The other thing that we've done within ODVA is we have highly encouraged people to make use of cryptographic acceleration hardware within their products. Obviously, this isn't something that you can really retrofit into a product because the hardware is already released, but for products which are being developed and are going to be developed in the future, this is a strong recommendation. The cost of this type of hardware has come down. Obviously, not all products are going to be able to implement this, but we hope that EtherNet nodes would be able to do this, and that would really help with the performance problem. Okay, so up to this point, everything I've talked about has been what's been defined currently in CIP security and what we are referring to as CIP security P1 or profile 1. CIP security P2 is going to be the follow-on effort that we're working on right now within ODVA to define the rest of what we call the big rocks of secure protocols. So the user level authentication, that's one aspect that P2 will cover. Security policy management for authorization, that's another one, and then security logging and auditing. We'll talk a little bit about those things. So user authentication and policy management. So again, previously the work dealt with device level authentication, but it didn't really have a way to communicate the human identity or the process identity that would be doing something. So this is the difference between two PLCs are talking, or I log into a computer, and even though the computer is authorized to talk on the network, I, as Jack, want to do something. So again, this is not just that the computer can communicate, but this is that I am allowed to download firmware to a PLC, or I am allowed to change the value of a tag or open a valve, things like that. So it's much more flexible, much more granular in terms of what you are configuring, what type of security policy is being implemented. we're looking at various token formats that can communicate identity and attribute information. Again, this is work that's going on right now, so we don't have everything fully baked, but it is something that's being recognized as very important and something that is absolutely necessary to be added to the CIP protocol. The other thing is the logging and auditing. So we don't have right now a central way to, or centrally defined way to do logging and auditing. There are ways that this obviously works, but within CIP, there's nothing defined. So again, this is something that is important. I think other speakers have touched on this already, but we in ODVA certainly recognize the importance of this. And we also recognize that syslog is probably the methodology, the technology that has the largest ecosystem for things like this. There are many, many open source tools and commercial tools that work with syslog. You have a lot of analysis tools that can be used. So, using syslog would allow us to take advantage of the large ecosystem, and you can configure syslog to work over a secure transport or a standard transport. There's a lot of flexibility with that. So that is what we're looking at for the logging and auditing. Again, that's not all completely defined right now. It's ongoing work, but that's what we're looking at doing next within the CIP security. Okay, so the other thing that I'll just touch on is what's kind of going on in the market right now. So recently there was a CIP security demonstration at this SPS industrial show in Nuremberg, Germany. Unfortunately, I don't have the hardware with me, but it was pretty interesting. We demonstrated a man-in-the-middle attack using EtherCap tool and a laptop that was doing a man-in-the-middle attack to change the speed of a motor and spin it in the wrong direction. But with CIP security, we had the secure transport, so it protected against that type of attack. And it was a multi-vendor demo. Rockwell Automation controllers, Danfoss drives, and an HMS gateway were all used in this. And they were all implementing CIP security to protect the industrial communications. And then again, ODVA is a multi-vendor organization. It's a standards group, so there are several vendors that are working on this right now, several vendors that are implementing it in their products, as well as working on the future plans that I spoke about with CIP Security P2 as well. Okay, thank you very much. That's what I had to say about CIP Security, and I would be very happy to answer any questions that you have.
How do you expect cert chain validation to work? So, like, what's to stop me as an adversary from using Let's Encrypt or something to make a cert and then just talking directly to a PLC?
Sure. Yeah, that's a good question. So you have to explicitly define the certificate authorities that you trust. That is one of the things that happens within the certificate object that I talked about, the CIP object. So if you haven't listed out a certificate authority as trusted, then the device will reject that communications as untrusted. And we do allow for some flexibility there. So you can define a certificate authority, or you can define trusting a particular endpoint certificate if you want to be more granular and say, I just trust this certificate.
Hi, you noted there'd be a performance hit, but that it might be mitigated depending on what type of encryption. Do you have any quantified values for how much of a hit that might be?
Yeah, you're not going to like this answer, but it depends. It's highly dependent on your application as well as the hardware you're using. We've seen everywhere between, maybe 15, 20%, all the way up to maybe around 30%, and it really depends. Obviously, when you have really small packets that are being communicated at a high speed, that's the worst case. When you have larger packets, it's not as bad. But it really depends. So, for those things like I/O, it's more recommended that you turn off, because that's where you have the small packets. So that's where we really recommend turning off the confidentiality and just using the integrity. But again, there might be cases where a user doesn't want to do that, so we try to give them the flexibility.
This might be getting into the P2 stuff, so it might not be defined yet. But for when you have sort of user tokens being passed along, do you expect that'll be on sort of a connection level or on a command level?
It'll probably be on a connection level, a session level, essentially. It probably won't be on a command level. That would be too many tokens going back and forth. But using the secure transport and then passing the token to establish session, and then that would probably establish what the user is able to do, and then whatever commands they send, that would be validated against the policy and the token that was sent.
That's what I was afraid of.
Yeah. More thoughts?
Well, I mean, I think in a lot of architectures, the communication session isn't established by a user, but by some sort of intermediary, data server, and then users are then sharing that data server.
Sure, absolutely. Yeah, I mean, that's something that we'll have to deal with. It might be that the user would have to, on top of that, establish their communication session. I mean, we would want to make that as lightweight as possible because we've already defined the secure transport and the handshake, the certificates, all that type of thing to establish a secure tunnel. So really, it could be as simple as just the token being passed down and the endpoint validating it.
Okay.
And I know in a lot of these kinds of things, some of the implementation details are where the vulnerabilities get introduced. Can you speak to anything that the standards body is doing to help ensure that vendors' implementation of the standard, preserves, the intent and the security of the standard? Does that make sense?
Yeah, that's a great question. One thing that we are doing is ODVA is defining an interoperability test, and it will test some of the capabilities that would be security capabilities, essentially. So it's not a strong security test. They're not going to do a penetration test on implementations. But at the same time, that test would at least allow for some level of assurance that someone has implemented the secure protocol correctly.
So TLS 1.3 is very imminently upon us. I know we're in the final draft, and that's looking pretty set. TLS 1.3 gets rid of quite a lot of the lesser used things than 1.2, and your presentation alluded to the fact that CIP Sec uses those lesser known features. What's going to happen then when they're no longer available in 1.3?
Yeah, that's a good question. I think especially the one that you might be referring to are the null cipher suites. I think, as far as I know, and I'm not at the forefront of this, but as far as I know, there's still kind of an open question about whether or not they're going to be allowed in TLS 1.3. I think there was leaning towards not allowing them. But I think we're going to have to deal with that. So, I hope that we can get them, as part of TLS 1.3. If not, we might have to define something specific for this, or we might have to look at something else. So, I mean, that's definitely something that's going to have to be dealt with when we move to TLS 1.3. As it's not completely ratified yet, we haven't totally have an answer for that yet, but it will be something that we will deal with.